we're about ready. Let's see. I'll get it until exactly 7. All right. What we're going to look at today is finish up a few things from last time where we were talking about our part cooling fan. I have printed, let's look at the new one I printed. I did get this one. Let's see where it is. This one. I tried this one out. I don't think I've ever printed this exact one. It comes in 2 different versions. This version is the one this is the one I printed. And this version where it has these tabs on the front where this one doesn't, to kind of slide over the little edge of the fan. Maybe it helps it hold it better. I printed this version without those just to, I don't know, just to see if that made installation a little bit easier than trying to get all of this stuff to line up. We'll see. It might be that this one actually works better. I just didn't print it. They're, I think, identical other than that. This one has a cool feature that you should be aware of. You can't really see it here. Let's see it. Oh, does it not let me? I don't think it's going to let me rotate it around. Well, we can look at the actual part though. Let's go over here and go to, it's still on the bed. Right there. So the cool thing about it is this little piece over here, if you look at the actual part that you're trying to get printed, let's see. Well, here it shows it. See, it has in the model built-in support. So like this is part of the model because it knows that, or well, the designer knows that that part is going to be an overhang that just can't print without some kind of support. So you can let the slicer, Cura, or whatever you're using as your slicer, you can let it do the support for you manually, or well, automatically, I guess. But sometimes it's better to just go ahead and build in the support yourself. So whoever designed this, Leo here, they built in the support, and not only that is this little support is going to be printing all by itself. You know, at the first many layers, you know, it's going to print several layers before it gets up to the actual part. And so they built in this little circle, and that helps adhere the support down. Instead of just having this little line of support that's trying to stick to the bed, they've got an entire circle that gets printed. So you can simulate that kind of thing with the brim setting in Cura. It will make these circles. This is actually part of the model. So the model that you get, the STL file actually has this already designed into it. So that's a way, when you know that your part's going to have support and you want to have a lot of control over exactly how that support gets created, is build it in the model and just remove it later. Usually, I don't know if you can tell in this picture, but you create a really small connection point between what you want to remove and your actual part. You can kind of see there's a little ridge right there. You can kind of see how they've done it. Maybe we can see it on the part once we get it off the bed. But that's one thing you can do with support material, is just design it as part of the model and clip it away or break it away later. So let's see what we got. It's actually stuck pretty well. Wow, actually really well. Let's see. Get it off of there without tearing up too much. All right, let's flex this bed because it really did get stuck down. There it goes. All right. So there's the little support thing that got built as part of the model. Can't really pick up the breakaway line, and there it is though. So see, that's what they built as part of the model, not support that Cura generated. They actually built this piece as the model, and then you just peel it off of there. So sometimes when you want support, it might be better to just build it as part of the model if you know it's going to need it, and you know the part's going to be 3D printed. So why not just build it into the model? Anyway, this is what we had. what we have. And like I said, I haven't printed this exact one before, so I don't know how well it's going to work, but I do see a little string down inside of it that I want to try and pick out of there. So yeah, I don't know if I can get down in there, and it's got a little stringy part. There we go. Okay, so it's going to take our fan over, where is it at? Right there. And underneath here is a little duct. I had the, I'll set the camera on it. I had the little Allen wrench. It takes a really tiny one. Let's get in there and get the old one off and see if we can put the new one on. Now, these are super tiny Allen screws. It is good to have a set of replacement screws so that you don't have to try and come up with something. There's the old part. It's just kind of a scoop. And this one's going to do a little bit more to redirect our air around the nozzle. We do need to make sure this is open. Yeah, looks like it printed open. It didn't close in. So we're going to put this guy right where the old one was. I mean, that fits really well. Just like that. Kind of glad I didn't print the model that had those extra little tabs, because I can see where they would be useful, but I can also see where they'd be really hard to print accurately because they're really thin. So I think this one will work well, or at least work well enough that I don't need those little tabs. Let's get this going. So this is a easy to get done upgrade. One of the optional assignments is to do an upgrade, so this could be a easy upgrade. Now, is it going to make a big difference? I don't know. Well, I think it will make a difference. I don't know if it'll be like significantly different. We're still using the exact same fan. We didn't rewire anything. We're just trying to better direct the airflow to cool the just printed filament. And so we're trying to get it closer to where it just printed and not only on one side of the nozzle. There are some of these that kind of surround the entire nozzle. I mean, I usually don't use those, but that could be useful too. You can run into some prints where it's obvious that you're cooling only one side of the print and the other side's being blocked from cooling, and so it's not as nice as the side that you are cooling. Let's see, let's go to our other little camera here and see if we can look at what it's looking like under there. So you can see the edge of it anyway, right there. I do have clearance. It's not going to scrape on the bed. You do want to make sure that it's not like drooping down below the nozzle, but it's not. It's pretty clear. And it's not touching the nozzle. If it were touching the nozzle, then we certainly would have melting problems. But it looks good. I think it's going to work. So I think that's a pretty good, simple upgrade. Almost free. You do have to pay for the filament, I guess, that you used. Here's another one that I haven't really even bothered to show you, but they make these things. Let's see if I can get a view of it. I have a lot of trouble getting the little micro SD card in and out of this spot, but they make these. This one even has some adhesive tape. You can mount it someplace, but these are just little USB card extensions, and it's a whole lot easier to deal with this thing where you can hold it and take the SD card out and put the SD card back when you need to, than it is to work in this tiny little area down here. So this is a useful, to me, extension, just because I don't even bother mounting it anywhere. I guess you could, like maybe there, but I actually like to being able to pick it up and manipulate the SD card. That's a lot easier to me than working in this really small area down here. So that's another thing that's pretty useful. I'm sure they make a variety of quality of those things. This one is not anything fancy. I don't even think it has a name brand on it. No. I don't see one, but if I find the link where I bought it, I'm sure I got it off of Amazon. Then I'll put it somewhere where you can see the type that I got. I don't think there's anything special about those things. So there's one thing we changed out. The other thing that I was going to look at today for kind of a upgrade that's not free, but it's useful, is I was having a little bit of trouble getting the part off the bed there, having to scrape on it. That bed, it's not attached any particular way except other than these little spring clips, which are fine. And so I took it off of there, and it was easy to pop this off. Also, before I get too far on that line, this print, you can print on this side, but this side is also one you can print on, particularly if for some reason you ever want to print some nylon. Nylon sticks to this side really well, where it has trouble adhering to other surfaces. But this surface is kind of like, it's similar to a circuit board that has nothing on it. It's similar to that material, and so you can actually print on this side. It's also, you can tell it's shiny. So the surface, I'm sure you've noticed now that the surface of your print surface gets imparted to the thing you printed. And so if you want a really glassy surface finish on one side of your part, that's another reason you might want to print on here, versus this one gives you a little bit of a texture. But they make other surfaces that are really textured. So I like this kind of surface. This is a metal bed. That's what I'm going to upgrade here in a second. Not with this one. This one goes to a different printer. But they make some of these. This is PEI. And PEI is a material that most of your printing material is filament. Once this bed gets heated, now it heats, maybe 80, maybe 85 or so. Once it gets up around that temperature, this PEI material, and it's just a coating on this. This is steel with this PEI coating on it. That PEI coating will actually bond to the print, the filament that you're printing, and make a really good connection so that it's less likely to warp. It can still warp. In fact, I had one, I think it was on this bed. I can't see the remnants of it, but it was on a bed like this one at least. It was a big part, and I thought, well, it's a lot of area that might have a lot of chance to warp, and it didn't warp, but it actually pulled the bed off. It warped to the point that it pulled the bed up. It flexed the bed enough to warp the entire bed. It wasn't this one, now that I'm thinking about it. This one's on a very strong magnetic bed. It was on one that's kind of a much cheaper version. But anyway, you can get these beds where it's a spring steel sheet, and then you have a magnetic bed sticker, basically. Now this one comes off of a Prusa, and it actually has magnets, like neodymium magnets, on the bed, and a lot of them. So this one, when it sticks down, it's not going anywhere. Most of the kits that you get in the $40 range or whatever, they're like this one. I haven't opened it yet, so we gotta see what I actually bought in here. I don't really remember what one this is, but let's get it out of there. Wow, it's might be taped into the box. Yeah, it is. I've never seen that before. They have it glued into the box so it doesn't slide around, I guess. Got some bubble wrap. So this is not. Oh, this is a heavy one too. This is a good one. So it's heavily textured. It's got just a magnetic sheet sticker, so super easy to install. And then I'm trying to unwrap the bed itself. The bed itself is heavily textured on both sides. Some of them you can get, one side is textured, one side is smooth. You can get both sides smooth, and then apparently you can get both sides textured, like this one. So I like these beds. So that PEI material, like I said, you heat up the bed maybe a little hotter than you had been heating. For one thing, now you also have to heat this magnetic sheet. So that's going to be a thing that's going to cause you to heat a little bit more than you had been heating. But this is just a sticker, and it's going to stick down here. I'm going to clean this before I actually stick it down. And then this will just pop on top of it. And it does a couple of things. One of them it does is that you can peel this off, flex the plate. It's spring steel, so you have a good amount of flex that you can do without actually yielding it, and pop your parts off of there. Also, these PEI coated sheets, like I said, they bond to the part when they're hot, but once they cool down, then they kind of release that bond and your parts can just slide off of there. And the other thing it does is the textured sheets give a nice texture to that surface that touches the build plate, which you can take that to your advantage. If maybe you are printing a part that has a face to it, you put that face down on the build sheet, and it'll pick up this texture, and it'll hide a lot of the fact that it was printed on that surface at least, and it'll look like kind of a injection molded grainy plastic. I don't know if I have a example I could show you right now. I will print something on this one and you'll see it, but I don't think I have anything handy that I could just show you. I don't see anything. So I'm going to get some IPA, isopropyl alcohol, always a good thing to have around printing, just because it's it dries or evaporates really quickly, and it's a good cleaner for removing oils and things like that. Plus, if you ever get into resin printing, we're going to talk about resin printing at some point later, then it's necessary for cleanup. So I've got some over here. I keep it in a little, let's see, little spray bottle thing. I'm just going to spray it on here. A lot of times, earlier on, maybe the first day even, I said you should clean your build surface and then never touch it again. That's, not always practical. You usually need to touch it somehow. So I will keep some of this spray around and just spray off the bed right before a print, and keep it clean that way. Now, this is a really large magnet, so it does take a little bit of making sure you actually have everything lined up. It looks like it's going to fit exactly, so that's good. You can trim these if you get off, I wouldn't hopefully don't get off that bad, but you can trim them if you somehow do get off that bad. Once they stick down, it's pretty much stuck, but you're not going to reposition it really. So hopefully we get close. Well, we got off a little bit. It's fine. Oh, well, so I say it's fine. You do have to make sure. I've ran into some printers that have a really tight clearance on this corner. And if you're off just a little bit, then it will actually rub. This one does not. So that's really all there is to, installing it. Looks like there's a little air bubble right there. Don't want that. So if that air bubble doesn't come out, I may have to pop it because I don't want to, like a bump here. Oh, actually, I might be able to peel it up enough to get back there to it. Oh, you know what? It's a piece. I don't even know where it got it from, but it picked up a piece of trash somewhere. All right. I think we got it out of there. Yeah. So I guess you could peel them off of there with enough effort, because that wasn't terribly hard to do. And then when you go to print, you just kind of drop that on there. and you've got this nice surface. You know, it takes you a few minutes to install it, and that's it. You can clean these with IPA. I probably should clean it since I don't know what, you know, the company did with it before I got it. This company did seem to take a lot of care with it, though. They had it packaged pretty well, and it's a nice heavy one. It's not a really lightweight spring steel. It's a heavy sheet of metal. So that tells me that it's pretty heavy. You know, it's still a thin sheet, but it's heavy. And I've got this new magnet on here, so I'm probably going to have to increase my bed temperature by several degrees from what I was to get the same effect I had before. Plus, a lot of times you need this PEI up hotter to really activate it to hold on to your parts. Now, there's some materials that can get stuck too well to PEI, so you do want to check your particular material. You know, do a little Google search or whatever to see, is that material going to stick too well to PEI? I'm thinking that TPU, the flexible stuff, it can stick too well to this, and you want to have some kind of release agent. Usually the release agent is just glue stick. So sometimes you use glue stick to kind of help things hold down. Other times you use just regular glue stick as a release agent for materials that want to stick too well to a particular bed. TPU, we'll print some of that later on, but it's a flexible rubbery material that when you print the part after it's done, it's a flexible part. It tends to stick really well to glass. So if you have a glass bed, and it can stick too well to PEI also. So it's one that you usually have some glue stick under it, not to help it stick, but to help it release later on after you're done printing. PETG can have some issues, particularly with glass. PETG can almost bond to glass, and we'll print some PETG. It's a really good material. You just have to be careful with what you print it on so that you don't permanently bond it to that surface. All right, so we got a really weird view there. Those are some cool upgrades. It also makes the printer, I mean, it's really nice looking. I might have to do something with this thing just kind of hanging out here. Although I do like it. Maybe I can mount it on the end somehow. But I kind of like it. There are some, I've seen Thingiverse parts where they take one of these and kind of print a housing for it, and it incorporates the control panel and the housing for that, and it kind of makes it look professional. I've never really printed one of those, but I can see where that would be nice to have that mounted somewhere. Let's see what else. I have not installed this guy. No reason I haven't. I just there's a metal one on there. It's not a driven one, so it's not one that has gear teeth on both sides, which this is better than what's on there. But it does have a metal one that's not going to just crack or something like that. All of these upgrades I'm showing you, I'm just showing you because they're things you probably will run into, and you should know the caveats to, like, should you install that. So like the caveat to this type of thing is you have to be able to get that whatever the existing drive gear is, you have to be able to get that off. If you can't get that off, then you can't put the new one on. So it does, oops, probably wasn't the best thing. Oh, this is a little thing you can print. Again, sometimes you want to hand feed the filament in and out of your printer without just like pulling on it. This little knob, there's plenty of these. I think a lot of the current Ender 3s don't have any amount sticking up past the little drive wheel though, so you couldn't actually attach it. But the bed, the caveat to that is that you're going to have to print a little bit hotter on the bed to get the same effect you were getting before, just because you're insulating between the heater and the top surface of the build plate. These are generally relatively cheap. Like, you can get a good one in the $20 range. The beds, the good magnetic beds are probably getting closer to 40 or 50 and higher. There's some really expensive ones out there. So it's a little bit expensive. This little thing, the only caveat to this kind of deal is that sometimes it doesn't recognize your SD card being inserted or not. So it can get a little bit, you end up having to unplug the cable and replug it in anyway. So some of those, can be an issue, but they're pretty cheap. And those are the only things we've actually upgraded so far. This printer does have a bed sensor, but we haven't really talked about that yet. What I did want to talk about is some of the G-code. So let's go over here in Cura. And there's a little part I sliced. I'll tell you what I sliced this at. Let's see. I sliced it at a 0.15 millimeter layer height. So that's about as thin as I ever want to print on this printer with the current nozzle. You can get, so the nozzle that comes on most all of these type printers to start with has a 0.4 millimeter diameter hole for extruding the filament. And in general, whatever size that hole is, you can print layers as thin as 25% of that, and as thick as 75% of that diameter. So I'm at the thinner end. I could go thinner, and those 25 and 75% are just kind of guidelines. There's no exact thing. You can do some really weird stuff intentionally to over extrude or really under extrude, but good safe guidelines where you're not trying to do some experimental type of thing is about 25% is as thin as you can go. 75% is about as thick as you can go without having to do a lot of other tweaks. So I'm at the thinner end. And I did the thinner layer height because this has open air chambers, down here. And I wanted to have the best chance of resolving all of those layers and not kind of like, if I made the layers too thick, it's possible. I don't know. I didn't even slice it that way. But it's possible that some of the things that are supposed to be open, actually the slicer closes them up because the layers are so thick. I don't think that it looks like this one is designed well enough where that wouldn't happen, but I wanted to just have a thinner part. It only took 30 minutes to print even at the thinner layer height, so it's like, okay, that'll work. So I did 2 walls. I didn't want it to be super heavy because I didn't want to weigh down the hot end. Now, is it going to really matter? Probably not, because the bed, now my bed is really heavy with this spring steel sheet on there and the magnet on there. The bed is really quite heavy now. So I probably am always going to be limited in speed wise on moving the bed back and forth. So whatever I print, this thing is really negligible to any kind of speed reduction I have to deal with. But I did 2 walls. I did 2 top and bottom layers. Again, there's actually not a lot of top. I guess this little section is a top layer and this little section. Actually, no, these are slopes, so these don't count as top layers. So I've only got a few top layers anyway, and I do have the bottom layers, down here that are, I did 2 layers of that. I did leave infill at 25%, although there's very little infill on the part anywhere. There's a little bit over there, and that's all the infill that actually ever gets printed for this part. Oh no, there's a little bit back there, a little orange. I kept it at the faster 70 millimeters a second. And it came out, I guess I should have showed you the print quality. It came out really well on this printer. It didn't have any quality. You don't want support on this one. So this one has the support built in. Another reason it has the support built in is that you could accidentally put support everywhere and plug it up so that it doesn't have the air passages. So see how it put support inside the thing? You'd never get that out of there. So all that blue inside there is the support it created, and you would have just clogged up your air duct. So that's why you could get away with that. You could put touching the build plate only so that it doesn't try to fill in the inside. But if you accidentally didn't do that, then, oh well, look, it still clogs it up right there. Still clogs it up. So that's another reason this part came with support, this support over here, built into the model itself, because if you click support, sometimes what the slicer is going to do is fill in stuff you didn't want filled in, and you don't have a way to get it out. Now, there is, not on this kind of printer really, but there are printers with 2 extruders. So Not going to be an Ender or Creality. I don't think any Crealities have this, or at least not any normal ones. There might be some out there that are kind of specialty ones. Usually not your low-end printers. The ones I can think of that are at the beginning of the low end, or well, I guess the end of the low end, like $800 or whatever, that have 2 nozzles. They're in the $800 range, something like that. I have one called a Bebo. Let's see if I can find a picture of it. This little guy. Well, okay, so $600 now. Now, I'm not recommending these. I'm just saying they're at the cheaper end of printers that have 2 nozzles. Because typically the multi-nozzle printers start getting a little bit more expensive. But they do make some printers that have 2 nozzles or more. And what you can do then is, let's go back to here. You can load 2 different filaments. And they make a filament called PVA, like PVA glue, which is water dissolvable. So you can, let's say that this is your part you needed to print, and for whatever reason you needed to put support inside the thing. Maybe you were having trouble with the top collapsing and you needed to support it, but then you need to get that support out of there, but it's trapped kind of in and you can't really peel it out. And what you can do then is print this on a printer that has 2 nozzles, load 1 nozzle with your model material, PLA, ABS, whatever it is, load the one that's going to print the support with a material like PVA. There are several of these materials. PVA is the most accessible one, and it's the simplest to remove because it just dissolves in water. And so all this blue stuff gets assigned to the nozzle with the PVA on it, and all the other model material gets assigned to the nozzle with the PLA in it. And then print the part, and you dissolve out you drop it in water for an hour or whatever, and you dissolve out all the support material. So there are ways to get internal supports like this that are clogging up all your passages, but you need them in there. There are ways to get them out on printers that can print 2 different materials. There are other setups where this kind of works, where you have 1 nozzle and you feed alternating patterns of your PLA and your PVA. That can work. It's not as clean of a solution, but it can work with 1 nozzle printers. But you need another attachment then, and usually those attachments that feed in multiple materials to make a multicolor print, or in this case a multi-material print, are more expensive than the cheap dual nozzle printers. So kind of, there are ways to do it. None of them are particularly simple. All right. What I really wanted to do over here, though, was look at some GCode. So I have got pulled up, well, there's our printer, but I've got this Marlin web page with the GCode index pulled up. I use this just because I can't remember all of the parameters for every, look at all these GCodes. All of these, most of these are M's, but all of these are different little pieces of codes. They're like command lines in a regular code that you might have seen before. These are all commands that do different things. So you can't well, you probably could eventually remember all of them, and you'll certainly start remembering the ones you use, but there are a lot of things. So these are Marlin. Marlin is the brand of firmware that pretty much all of these printers start out running. You might, we'll change firmware at some point along the quarter, just so you can see how it's done if you want to actually edit the firmware itself. But right now we're just going to assume that all of these are running some kind of Marlin, which means they can interpret these different codes. Now, where'd Cura go? Here we are. So let's go over to prepare so that we can see our machine and manage printers. And what I wanted to look at was machine settings, this start and end GCode, that these are the defaults. We haven't changed any of the stuff here, but I wanted to copy these. Oh, can I not copy them? Oh, wow. Maybe I can only edit them here. I can't highlight and copy them. That's kind of disappointing. Well, let's just look at them here then. because I wanted to make them where you could see them easier, but it doesn't look. Oh wait, maybe it is highlighting, but it's highlighting in this super light gray. All right, it is highlighting them. It's just not easy to see. I usually use Notepad++. Notepad will work fine to edit any kind of G-code. Word is typically not going to work. So a word editor like Word or Docs or something like that, you can certainly paste your G-code in there and type around on it and all that. I could type in this window I'm looking at right now. I just want to be able to change the font so you can actually see what I'm doing. But the problem with using Word or Docs or something like that is when you go to save it, typically it will embed some kind of header, like information about what software wrote it, who wrote it, you know, the author, all that kind of stuff, and it can embed it in a way that the machine can't interpret that. So it doesn't embed them as G-code comments, you know, with a little apostrophe in front of it or whatever. It embeds it as just these comments, and your machine doesn't know what to do with that, and so it can cause errors on reading that file. So Notepad and Notepad++, being just text editors, won't do that. So let's do File, New, drop in our code there. So this, I just copied this straight from the Ender 3 Start G-code. So this is what Cura decided the G-code should start out looking like. So let's start learning a little bit of G-code on what these lines are doing and what can we do to make them different. Oh, I said apostrophe is the comment. The semicolon is the comment indicator for G-code on this Marlin stuff. All right. So it starts with a G92E0. So the E is going to refer to extruder. 0, this is a computer, and so a lot of times you don't start counting at 1, you start counting at 0. So E0 is the first extruder. We only have one extruder, but you can have printers that have multiple. Certainly you can have printers that have 2, but there are some printers that have many different extruders. And so yours probably just has E0 here. But there are reasons you might have E1s if you have a dual nozzle printer. We'll look at that sometime later in the quarter. So G92, let's see what G92 does in our little firmware code here. So G92, set position. So what this does is it takes wherever it currently is. In this case, it's talking about the extruder. And it's not talking about the position of the nozzle. It's talking about how much filament has been extruded. And it sets that wherever the current position is to basically 0. Start counting from here. And so that's what this command you probably don't actually need, because this is the very first thing that you haven't done anything in your print yet. So it's fine to start at 0 wherever it's at. But this is just enforcing that the current amount of filament extruded is 0. Even if there's some filament leaking out or whatever, it hasn't purposely sent any filament through the feeder into the hot end. So just saying that you're starting at 0. That line could probably be omitted. These, you might have ran into people trying to optimize code and make every line as fast as possible, nothing unnecessary. That's really not a thing for what we're doing here. There is one piece of it that that we can optimize later on, and it's a plugin for Cura or for Octoprint when we get to that. But we'll get to that later. But this is just, it's not going to slow us down to have an extra line that resets the extruder. All right, but that's the first line, what it's doing. G28, and the good thing here in this Cura startup code is they comment everything, so you kind of know what everything's doing. But G28, whenever you type that in, and you can type these commands directly to the printer if you're connected to it wirelessly or through a USB cable. You can actually talk to your printer, send it G-code commands. I am not connected to this printer, only through the USB or the SD card. So I can't actually communicate with it other than loading files on the SD card and it reading those files. But you can plug in a USB cable and talk directly to your printer and have it talk directly to your computer. But G28, that's the home all. So it's going to home X, Y, and Z in that. You usually have to do that before you try to print anything. A lot of your printers won't even let you move the nozzle around until everything's been homed, because it doesn't know anything about where the nozzle is, and you go moving around, it might crash into something. All right, here, this G1, so there are G1 and a G0. So let's look at those. This one doesn't have any G0s written in the command here, but they're kind of paired together. So let's look at G1 and G0. Actually, that's what it's on right here. Those are linear moves. So the linear is not like talking about accelerations. It means straight line from one point to another, from where you are to this new point. So just take a straight line from wherever you are to this new coordinates. So you don't give it to like a start point and end point. The start point is just wherever it already is. And the difference in G0 and G1 is that the speed. So here you can kind of see G0 is your rapid movement. So you're not printing when you do G0. You're just kind of moving from one place to another, and you're not trying to extrude any filament. G1, both of this, G0 is rapid linear, and then it says G1 is rapid movement. That's kind of weird. G1 is normally the slower one where you're wanting to actually print. But I'm reading this now, and the way it's reading is kind of awkward. But I guess that's just the way they wrote it. Anyway, I want to be able to actually move and print some filament. This first one, it's not actually printing anything. In fact, it says move the Z-axis up a little bit to prevent scratching of the heat bed. So I've just homed everything. It's in at 0, 0, 0, or well, it's not necessarily at 0, 0, 0, but it's at its home position, wherever that might be. And I want to make sure that it is not touching the bed, because it could be that home position is at 0, 0, 0 and the nozzle is directly on the bed surface. So that could be true. Now, what you'll not see in here, in this particular version, is it didn't look like it heated up the nozzle or anything. That's actually built in already. It's just not showing it in the start G-code here. Cura now builds it in separate. So it is heating the bed and nozzle before it tries to print anything or do any of that kind of stuff. But it's not showing up in this custom G-code that you can go edit. To edit that, you have to get into other parts that I'm not even sure Cura will let you do without like downloading the G-code and editing the G-code. So here, what this is G1, so go at my slower speed, Z 2.0. So what that means is go up to 2 millimeters, or I guess it could be down if you're above 2 millimeters, at a F3000. So F's are feed rates. How fast are you going to move? These are in, I think, millimeters per inch. I don't remember the units on this. I think it's, no, millimeters per inch. Millimeters per minute. I think that's the units on here. We could check that out to be sure. But so this is 3000 is a faster, not super fast, but faster. Here's a 5000. Faster move speed. So even though G1 kind of has a move speed associated with it, you can override that and give it a particular moving speed if you want to. So what this does is it basically just takes wherever the nozzle is and moves it up, or moves it to 2 millimeters. It doesn't necessarily move it up, it just moves it to 2 millimeters. There is a difference, and this is not showing in our start G-code, but there are two commands, G28, no, not G28, 92, isn't it? Yeah, 90 and 91 right here. Now, what these two commands, if you want to have control over, do you want to send a command and go to a position like 2 millimeters above the bed surface, or do you want to just wherever you're at go up 2 millimeters? So that's the difference in absolute positioning and relative positioning. So you can send a G90 command to say that all of these commands I'm about to send for moving around are all talking about absolute position. So Z 2.0 means go to a Z height of 2.0 above whatever Z equals 0 is. Or you can send the G91 command to set it into relative positioning mode, and then and here, you know, they're going to give you an example. It's just for type G91 is all you do to turn on relative positioning, and you just type G90 to turn on absolute positioning. Most of the time you want to be in absolute. But there are some reasons where you just want to, you don't necessarily know where the printer nozzle is at this particular time, but wherever it is, you want to quickly go over to relative positioning, move it up a certain amount of millimeters, and then go back to maybe a relative position or an absolute positioning to move to a certain location. There are reasons you might want to switch between absolute and relative. So you can do that. You can tell it to move relative to where it is, or you can tell it to move to a specific place. Most of the time you're telling it specific place with absolute positioning. That's what's happening over here. It doesn't have like, we could have forced that with a G90 command, you know, and now we're for sure in absolute positioning mode. That's already the case, but you can force that to happen also. And you can force it to do the other. You can force it to do relative. So this one is, I'm in absolute positioning, but I didn't put in X and Y coordinates. I just put Z. So whenever you don't put a particular axis, you don't put X or Y or Z, whichever ones you leave out, it means keep those the same wherever you are in X and Y, but change this other one. So what this is just go straight up. Don't change X and Y, just move Z to 2 millimeters. This one would have been a little safer. Like a lot of times this move Z axis up is written like this. G91, so that I'm in the relative positioning mode. And then what this Z means is wherever you are, go up 2 millimeters, and then you go back to G90. Now go back to absolute positioning. So this would be a little bit safer version, so that I don't know, for some reason there's something blocking the path between wherever the nozzle is and the 2 millimeter absolute coordinate. This one, this way, just makes it move up 2 more millimeters from wherever it's at. That's not the way they did it here, but that's a way that it's commonly done also. All right, so I am now 2 millimeter. I'm at Z equals 2 millimeters, and X and Y are just left off wherever they are. Usually after you home, we did do a home here, so usually they're off on the bottom left corner, or in the middle of the bed, whichever homing routine your machine does. And now, just in case I am in the middle of the bed, I want to start creating that purge line. So my machine is set up where it prints the purge line along the left-hand side of the bed. So I go at my 1 speed. I go over to X equals 0.1, Y equals 20, and now the Z is dropping down to get to close to the bed. So it doesn't really care what my layer height is. When you're doing this purge line, you're trying to spit out a bunch of filament to get it flowing really well. So when you start printing your actual part, your filament's already flowing. So it's 0.3 millimeters. So that's a really thick layer, right? So this moves over to the bottom or the front left corner of your bed, and it's sitting 0.3 millimeters above the surface. And it used a relatively fast feed rate to get there. So 5,000, I think it's millimeters per minute to get there. Then this one is very similar. In fact, this one they actually do repeat the X coordinate. You don't have to do that, but they did. So X 0.1, but Y has been changed to 200. So I've basically moved Y 180 millimeters in the Y direction. I've kept Z the same. I'm going a little bit slower, 1500. And then E15. So what this does is, it's not like the 15th extruder. This is when E is embedded in a G line. This E is talking about how much filament are you going to send through the feeder, send through the extruder. So the thing with that is that it is cumulative. So up here we set that we were at 0. We have, oh, that might, I think that's still E0, the first extruder, not an amount of 0. But it starts out at counting at 0, and you're going to spit out 15 millimeters of filament is going to run through your feeder and come out of the nozzle. Then I move over a tiny bit, so I keep the Y and Z the same. I don't extrude, there's no E on here. I move X over 0.3 millimeters, so I just move over to the side a tiny bit. And then I come down, so keep X the same, but Y goes back down to 20. Keep the Z at the 0.3 millimeter height I've been using, relatively slow. And now E30. So my extruder counter, so it's keeping a count of how much filament has been extruded. It extruded 15 millimeters to get to do that first purge line. And then another 15, so the cumulative amount is 30 now. So if a common mistake here is like, oh, I wanted 15 going one way and 15 going back the other way. What that would do is it actually wouldn't extrude any filament at all on the second pass, because it's already at 15 amount of filament extruded. So this is a cumulative total. So 30 more, or 15 more to get to 30 total. So that does my 2 purge lines. If I wanted to add a third line, for whatever reason, let's move over another 0.3 millimeters. Let's go ahead and code every one of these in. We'll stay at Y20, and we'll stay at Z 0.3. We'll move over. We're just moving over to the side, not extruding. So we'll do the faster feed rate. So move over again, and then now we're over a little bit further to the right. G1. Now basically we just want to copy this first line, but we have to change it a little bit. So we're at 0.7 now on our X. Everything else can stay the same, but we want to add an additional 15 to our cumulative total, so 45. So now I've got 3 purge lines. It purges towards the back, it moves over, comes back towards you purging, moves over, purges back towards the back. So the nozzle is sitting at the back of your printer now. So maybe you're noticing that your printer just takes extra long to purge and get really flowing, free-flowing filament when you go to print your model. You can make these do patterns. You can make you can make it go along the front edge of the printer, so you can really see what's going on. Sometimes you'd rather see the purge and make sure it's working versus trying to look at it when it's on the side there. You could redefine all your X and Y coordinates here, and make it purge along the front edge. I will say purging along the front edge is a little bit dangerous, because sometimes you have your little spring clips there and you might hit them. So you want to make sure you don't run into the spring clips. So you want to be far enough back in the Y direction that you wouldn't hit those. So that's, I don't actually want mine to do this, but you could make zigzag patterns or circles or whatever you want it to do. What I usually do is I do the 2 purges along the side, and then I turn on skirt in the slicer so that I get a couple of extra purge lines around the part. That lets me check a couple of things. It lets me check to make sure that the place that I put the part it's going to print looks correct. It's not printing off to the side, or it's not overhanging the bed or some weird thing like that. And that it's that section of the bed is more or less level. So it gives me a couple of traces around the actual part to fine tune the bed, turn in the corner knobs to get that skirt printed just right. before it starts printing the actual part. So here we go. It has been extruding some filament during this, so it's like, all right, now we're about to start the actual print. So we're going to reset the extruder to 0 again so that it can start counting on the actual print. It moved the nozzle up off the bed. The nozzle is 0.3 millimeters off the bed right now, but it needs to traverse over to where it's going to start printing at, so it moves it back up a little bit. And then move over to prevent blob squish. So what's it doing here? Oh, because you left the hot nozzle sitting on top of, or at least above, because you just raised it up, above the stuff you just printed, it could drool and kind of connect to that stuff you just printed, so it just moves it off to the side some. Okay, so that's what happens in your start G-code. Well, what time is it? Oh, let's look at the end G-code just real quick, and then we'll call it a day, and we'll come back next week with some more upgrades and things like that. But let's look at the end code real quick. I'm not actually going to replace any of these, but sometimes the end code, let's see, line 17 starts our end G-code. So let's get it up there. So I've just finished printing the part. Now what it's not showing me is that there's a hidden G91 command that you're not seeing here. It's not in the, actually no it is, I just didn't copy it. G91. Alright, I guess I just didn't get that copied. Let's get all the, it's hard to see where it's actually selecting there. There, we got it. Alright, so there's the G91. So I'm in relative positioning. So where, because you don't know every time where the part is going to finish with the nozzle. So wherever it finishes, switch into relative positioning and retract. So I've got a negative value on my E extruder. So retract a little bit of filament so it's not like leaking onto the part I printed. Retract some more, but also raise up the nozzle a little bit. Here's a move over to X and Y of 5. So that's called wipeout, but it's what it's doing is it's just moving it over to the side so it doesn't kind of leave a little string blob on top of your print. Raise up Z some more. Go back to absolute positioning. Now that I've got the nozzle out of the way of the part, it should be in a safe spot. I can go back to absolute positioning, and then here, this machine depth, that's actually written as a variable that Cura knows. When you set up your machine, you put in, or at least somebody put in, if you didn't put it in and change it, then the profile put in X and Y and Z sizes for your print bed and your machine. So this is using that, this is using that machine depth variable that was inputted when you put the original profile together. Then it turns off the fan, turns off the hot end, turns off the bed heater. One thing that I do like to add to here usually is kind of present the part. So push the bed forward. Push the bed forward. So you might do a G1, assuming that you've got the nozzle off, back out of the way of all your part, then you can do it, and it's above it all. So you can do a present where you do like move the nozzle, which is actually moving the bed. So all of these coordinates are kind of thinking of the nozzle moving, but it's actually in our printer, the bed is moving in the Y direction anyway. So move the nozzle to Y of 220 or 200, depending on how deep your bed is. Maybe just 200 for us, just to be safe. I don't know if it cares that Y is capitalized or not. So this would be present part. So it would actually take and push the bed towards you so that it's easier to get the part off of there. And so sometimes that's built into the encode. It's not on this particular one. You could do this also, M84, just disable the stepper so you can manually move the bed around by just moving it. That's usually a good thing. Actually, it didn't disable Z. So it's not going to just, the axis isn't just going to fall. Most of these printers have enough resistance in them and the lead screw that's holding the Z-axis, that they're self-locking and they don't just fall. But there are some printers that if you release the Z stepper motor, the gantry, whatever it has, will fall. That's not very common, but it does happen on some printers. Usually not on Ender 3s. Okay, so that's kind of a intro-ish to your basic G-code commands. The ones that you use most of the time anyway. There are, like I said, I did put the link to this page in Moodle. It's just Marlin Docs G-code. Or, well, actually, that's the whole thing. That's this particular one, but I think Marlin Docs G-code might get you to this spot. It is a .org, it's not .com, so you have to be careful with that. But there are a lot of commands that you can start playing around with when you want to. You don't need to do any of them, but sometimes you want your printer to do a very specific thing, then it's good to be able to go in there and write something. One thing I've seen is a little wire brush, with the little bristles on it, like a big giant toothbrush. You can mount those and kind of wipe the nozzle clean so it doesn't have any drool or anything hanging from it. And so you might want to write a little routine to go over where that nozzle, that brush is, and wipe the nozzle across it a few times before it starts printing. It has this clean nozzle thing. I'm actually not sure what this does. It does give you basically move back and forth, but you have to have something under it to actually clean. You could use the bed, I guess. But I've seen it done with the wire brush, like you go to Harbor Freight and get a little cheap wire brush head, cut off the head and mount it so that the nozzle can wipe across it to clean off anything that might be on the nozzle left over from a previous print. All right, we will come back on Monday and we'll look at changing the nozzle and maybe some manual mesh leveling. I'll print something on our textured bed so you can kind of get an idea of the surface finish that you can expect when you use one of these textured beds. I'll see y'all next time.